Happy morning, children. I am your physical science teacher. I hope you are all doing good. Congratulations, children. We successfully done August monthly test. I am really happy about your progress. Next, you have to concentrate for September monthly test. Children, we already completed in physics, lesson number 1 laws of motion and lesson number 2 optics, and in chemistry, lesson number 7 atoms and molecules, and lesson number 8 periodic classification of elements. In this lesson, we discussed some of the topics. In continuation of this 8th lesson, in today's class, we will learn about metallurgy and the process obtaining pure metal from ore. Ores contain all unwanted impurities and are part of a required metal too. The process used for the extraction of metals in their pure form from their ores is referred to as metallurgy. Metallurgy. Human life is associated with various metals. We use metals in our day-to-day activities. It is the utmost need to have some metals like sodium, potassium, calcium, iron, etc. in the human body. Deficiency of these metals affect the metabolic activities, thereby causing diseases. So, metals play a vital role in our life. Metallurgy is a science of extracting metals from their ores and modifying the metals into alloys for various uses based on their physical and chemical properties and their structural arrangement of atoms. A metallurgical process involves three main steps as follows. First step is concentration or separation of the ore. It is the process of removal of impurities from the ore. Second process, production of the metal. It is the conversion of the ore into metal. Third process, a refining of the metal. It is the process of purification of the metal. Methods of obtaining pure metals from their ores. First step, crushing and grinding of ore. Second one, concentration of ore. Third method, roasting, calcination and smelting. Fourth method, a reduction. Fifth method, a refining of metals. The first method, the crushing and grinding of ore. This is the jaw crusher. Ores are crushed into a fine powder in big jaw crusher and ball mills. This is the ball mill. This process is called pulverization. After pulverization, the ores are concentrated based on the type of impurities and their percentage proportions. Next, terminology in metallurgy. First one, minerals. A mineral may be a single compound or a complex mixture of various compounds of metals found in the earth. Or the mineral from which a metal can be readily and economically extracted on a large scale is said to be an ore. Next one is mining. The process of extracting the ores from the earth crust is called mining. Next, gangue or matrix. The rocky impurity associated with an ore is called gangue or matrix. Next, flux. It is the substance added to the ore to reduce the fusion temperature and to remove the impurities. Example, calcium oxide, basic silica is acidic. If the gangue is acidic, then basic flux is added and vice versa. Next is slag. It is the fusible product in formed when a flux reacts with a gangue during the extraction of metals. See, flux plus gangue gives slag. Next one is smelting. It is the process of reducing the roasted metallic oxide from the metal in its molten condition. In this process, impurities are removed as slag by the addition of flux. See here, this is a smelting. So it is a melting operation in which the constituents of the ore are in melted form. Next, types of separation or concentration of an ore. Here there are four major types of separation of ores based on the nature of the ore. First one, oxide ores. Second one, carbonate ores. Third one, halite ores. Fourth one, sulfide ores. We'll see oxide ores. First one, bauxite. Formula for bauxite, Al2O3.2H2O. Next, cuprite. Formula Cu2O. Next, hematite. Formula for hematite, Fe2O3. Next, ores, carbonate ores. First one, marble. Formula CaCO3. Second one, magnesite. Formula MgCO3. Third one, siderite. Formula FeCO3. Third word, halide ores. Cryolite Na3Alf6. Fluorspar CaF2 formula. Next, halide word, rock salt. Formula NaCl. The fourth ore is sulfide ore. For galena, formula FbS. Next one, for sulfide ore, iron pyrite. Formula FeS2. Next, zinc blende. Formula ZnS. Concentration of ore is divided into three things. First part is concentration or centrifugation based on varying density. Second process, flotation method. Third process is a magnetic separation. We'll see one by one. The first method is hydraulic or gravity separation method. This is the diagram. Hydraulic washing of the ore. This is crushed ore. This is water is coming. It's a corrugulated boards. This is the sloping table. Gang with water is collected here. We'll see the principle. The difference in the densities or specific gravities of the ore and the gang is the main principle behind this method. Oxide ores are purified by this method. Example, hematite. Formula for hematite is Fe2O3, the ore of iron. Next we'll see the method. The ore is poured over a sloping, vibrating coagulated table with grooves, and a jet of water is allowed to fall, flow over it. The denser ore particles settle down in the grooves, and the lighter gangue particles are washed down by the water. Next method is magnetic separation method. See, this is the diagram. We'll see the principle. The magnetic properties of the ores form the basis of separation. When either the ore or the gangue is magnetic, this method is employed. Example, Tungsten formula TSNO2, the ore of tin. Method. The crushed ore is placed over a conveyor belt which rotates around two metal wheels, one of which is magnetic. The magnetic particles are attracted to the magnetic wheel and fall separately apart from the non-magnetic particles. See, this is the diagram. In magnetic separation, the pulverized ore is placed on a conveyor belt that has two magnetic wheels. This is the magnetic wheels. Next, this is the traveling belt. See this one. These are the two magnetic wheel. This is the magnetic particles collected here. The other side, non-magnetic particles are collected here. The magnetic particles are attracted to the magnetic wheels and fall separately apart from the non-magnetic particles. Third process is froth flotation. See this a diagram. This is the diagram. Here you see the compressed, here this is the compressed air is coming. Here this is the sulfide ore particles, below water containing pine oil, the below is a gangue. Here this is the froth bubbles carrying sulfide ore particles. See, you see here. Okay, you see the principle. This process depends on the preferential wettability of the ore with oil, the pine oil, the gangue particles by water. Lighter ores such as sulfide ores are concentrated by this method. Example, zinc blind. Formula ZNS. We'll see the method. The crushed ore is taken in a large tank containing oil and water and agitated with a current of compressed air. The ore is wetted by the oil and gets separated from the gangue in the form of froth. Since the ore is lighter, it comes on the surface with the froth and the impurities are left behind. Example, zinc blind. Formula ZNS. See here. Froth flotation is used to concentrate ores that are in sulfide forms. See, ore preferentially wetted by the oil and hence floats on the top as a foam. See here, gangue preferentially wetted by the water and settles down. See here, this is the gangue particles. Here this is the water containing with pine oil. Here this is the compressed air. Here this is the fourth bubbles carrying sulfide ore particles. Here you see here. The ore wetted by the oil separates from the impurities or gang in the form of froth. Heavy particles like clay, sand, etc. became wet and settle at the bottom. See here, this is the copper concentration of the ore, flotation, copper. This is the lead. This is the zinc. The concentration of sulfide ores of copper, lead, and zinc metal are carried out by froth flotation method. Next, the sulfide ore is removed. You see here with sieves in a second vessel, and washed with water. The last method is chemical method or leaching. This method is employed when the ore is in a very pure form. The ore is treated with a suitable reagent such that the ore is soluble in it but the impurities are not. The impurities are removed by filtration. The solution of the ore, that is, the filtrate, is treated with a suitable reagent which precipitates the ore. Example, bauxite. Formula Al2O3.2H2O, the ore of aluminium. Next, we'll see occurrence of ores in Tamil Nadu. First, limestone, Coimbatore, Kadalur, Dindukkal. Gypsum, Trichy and Coimbatore districts. Titanium minerals, Kanyakumari, Tirunelveli and Tuticorin. Next, chromite, Coimbatore and Salem district. Next, magnetite, Dharmaburi, Erode, Salem and Tiruvannamalai. Next, tungsten, Madurai and Dindukkal. References also given. Reference, Mineral Sources of Tamil Nadu, ENVIS Center, Tamil Nadu. Children, write the assignment in your notebook and submit it for correction. Thank you.